All right, Unit 1, Learning Target 2, we're going to solve a linear equation. All right, so on yours you have up to step 5. I'm going to do it one step at a time. Follow along with me. All right, so eliminate the parentheses, so we're going to distribute. This is a distributive property. So here, all we're doing is we're taking the number outside the parentheses. It means multiply, they're touching. We're going to distribute. So I do 3 times x, which is 3x. 3 times 4 is 12. So I want to make this clear. If it was negative 3 times x plus 4, I would be distributing a negative. Negative 3x minus 12. All right. Step 2, add like terms on both sides. So like terms would be like 7y negative 3y because they both have a y to the first power. 2x squared y 15x squared y. They're like terms because they both have x squared y. But like 7x and 3y, they're not like terms because one's an x and one's a y. So here, my like terms are 2x and 3x. They're both positive, so I'm going to add them. So that would give me 5x. I still have plus 4 equals 20. Step 3, make sure the variable is only on one side. So what this means is that we want it to get up. So if I have an equal sign, I want the variable, so normally we have x, so I'm going to put it as x. We want normally x to be on one side and a number to be on the other. Or it could be this way, the number's on this side of the equal sign and the x is on this side. Oh, you can't see x. And the x is on that side. So it doesn't matter. So the way that I like to think of this is the easiest way for me to do this is there are 2 terms on this side. There's 1 term on this side. So I'm going to move something on the side with 2. So I look over here, this is a letter, so I want to move a letter over here to there. So moving 1 on the side that has 2. So if I do this, I'm going to minus a 6x from both sides. This was a positive. I do the opposite, I minus. So then I'm left with 4 equals 2 minus 6 is negative 4x. So I'm going to just show you what it will look like if you would have moved the 2x. So over here, so if we did 6x plus 4 equals 2x, and just say you move this 2x, so it's a positive, we subtract, we do the opposite. Then you would have this, 4x plus 4 equals 0. If you look up here, I have a number and a letter. Number equals a letter. Here's one term, 1 term. Here I have 2 terms, 1 term, which is just the same as this. It didn't really do much. So that's why I always, with the side that has 2 terms, move one of those terms. If there's a constant, so this is the same thing. We're going to move the constant now. So if you look here, there's 2 terms over here. There's 1 term over here. So this one has 2 terms. So I look over here. This is a number, so I want to move a number on this side. This has the 2. I'm either moving a letter or a number. This side's a number, so I'm moving a number. This is a plus 7, so I'm going to do the opposite. I'm going to minus 7. These will cancel and give me 0. I don't need to write the 0, so I have 3x equals 19 minus 7 is 12. Step 5, eliminate the coefficient. The coefficient is the number touching your letter. So my coefficient here is 3. Here, my coefficient would be 2/3. It could also be written like this. It's still 2/3. You just do the opposite. So since these are touching, that means multiply. The opposite of multiply is divide. 3 divided by 3 is 1. 1x is the same thing as just x, so I'm not even going to write it like that. I'm just going to write x. X equals 12 divided by 3 is 4. So I'm going to show it to you all now in like one thing. So here, I have 2 terms on both sides. I have x and number on both sides. So I just want to get x's on one side, numbers on the other. It doesn't matter which one. The way that I do this is I see that this is a minus 6x, and if to do the opposite, I would have to add it, and if I add it over here, it becomes a positive. If I moved this 5, I would have to subtract it, and then it would be a negative. I prefer to try and not use negatives. So I'm going to add 6x to both sides. So then this is going to cancel, and I'm going to be left with 16 over here, and then I'm going to have 11x minus 6. So now I have my 2 and my 1. So I want to move one of these over here. This is a number, so I'm going to move a number. I'm going to move this minus 6. To move a minus 6, I'm going to plus 6. These will cancel. 11x equals 22. They're touching. I want to do the opposite. That means multiply, so I'm going to divide both by 11. So whatever I do to one side, I have to do the other. I add 6, I add 6. I add 6, I add 6. I divide, I divide. So then I have x equals 2. To check if you're right, you can always check if you're right, and I'm going to show that down here. All you're doing is taking that value that x equals 2, and you're plugging that in for both values of x and seeing if it gives you a true statement. So that first side on the left, it would be 5x, but x is 2, so 5 times 2 minus 6. 5 times 2 is 10, 10 minus 6 is 4. Now let's go on the right. So I have negative 6 times 2 plus 16. Negative 6 times 2 is negative 12. Negative 12 plus 16 is 4. They both, so 4 equals 4, that's true, I know I'm right. If I got 4 equals 9, that means my answer of 2 would be wrong. If I had, this was 4 and this was 9, they're not the same number, I would have been wrong. I would have to go back and check my work. Over here, the first thing I'm going to do is I'm going to distribute. I'm going to get rid of my parentheses. I'm distributing, though, a negative 8. So I'm going to have 4x minus 8x minus 8 equals 8. My next step is I'm going to combine like terms. On this side, I see I have 4x and a negative 8x. I can combine them. I can combine, oop, not green. So 4x minus 8x is negative 4x. I still have minus 8 equals 8. I have two terms, one term. I have a number here, or variable here, a number here, so I want to move my number. Plus 8, plus 8. This is going to cancel. So I have negative 4x equals 16. I'm going to rewrite this up here. Negative 4x equals 16. I'm going to now divide both sides because it was multiplication. I'm dividing note by a negative. This is a negative 4. I divide by a negative 4. So x equals negative 3. All right, down here. This one is easier than this one, so I'm going to explain that. So here, I have x divided by 3, or x over 3 minus 3 equals 15. So I have two terms, right? I have a number here and a number here, so I want to move this 3. So to move this 3, I'm going to plus 3. So this is going to cancel. I still have x over 3 equals 15 plus 3 is 18. All right, so this is x is being divided by 3. X is being divided by 3. So the opposite of divide is going to be multiply. So we're going to multiply both sides by 3. This cancels. So x is going to equal whatever 18 times 3 is. I'm going to do this because I don't know if 8 times 3. 4, 2, 3, 4, 5. So 54. All right, this one, similar. I'm going to show you two different ways to do, no, I'm just going to show you one because the other way would only work if we had two fractions and we don't. So again, I'm going to do the same thing. Number, let's move it. So I'm going to minus 4. So I'm going to have 2 over 5x equals 8. This x is being divided by 5. So the first thing I can do is I can multiply both sides by 5. All right? So when I multiply by 5, this 5 is going to cancel with this 5, just like the 3 canceled with the 3. So if I think about this, this would have given me 3x divided by 3. 3 divided by 3 is 1x, which is just x. Same here. They're just going to cancel. So then I'm going to be left with 2x equals 8 times 5 is 40. Now this looks just like over here. Then I divide by 2. These will cancel. X equals 20. Alrighty. Special cases. So let's first solve them out and we'll see what that looks like. So first I'm going to distribute, get rid of my parentheses. So I'm going to have 2x plus 8 minus 5 equals 2x plus 3. I'm going to combine my like terms. I have a positive 8. I have a negative 5. So I'm going to have 2x, 8 minus 5 is a plus 3. I'm going to stop you right here. We could keep going. But do you notice that 2x...
Rachel Burridge to the office, please. Rachel Burridge to the office.
2x plus 3 equals 2x plus 3. That is a true statement. So if I wanted to keep going, and I will now, okay, let's get my numbers to one side. I'm going to subtract 3 from both sides. I'm going to move this 3. So when I do this, I then have 2x, and then I have 2x. There's still this. So this was the same. This is also the same. If I want to get x by itself, I can divide by 2. So then I would have x equals x. It's all the same. That's a true statement. That means I can plug any number in here, so I can plug in 5. So this means I have infinite solutions. I have infinite solutions. If you get something where it's the exact same equation equals the exact same equation, that means you can plug in any number for x and it'll be true. You can plug in 4, and 4 on both sides will work. I can plug in 7, I can plug in 15, I can plug in -9. Infinite solutions. All right, over here, first thing I'm going to do is I'm going to combine some of these like terms. So 4m minus m is a 3m. I still have plus 1 equals 3m plus 9. All right, I'm going to get my numbers on one side. I'm going to move this. I'm going to move a 1. So then I have 3m equals 3m plus 8. Now I have m and m over here, so I have to move my variable to get it to work. So these are going to cancel, well, and so I'm going to be left with 8 on this side. 3m minus 3m is 0, so I get 8 equals 0. This is not a true statement. 8 does not equal 0. So when you get something where it doesn't equal something, it's going to be undefined. Or you could put no solution. So I would rather have you put no solution. Let's not do this one. So no solution. And those are two special cases. It's either infinite if they equal each other. If it's something like a number equals another, like 7 equals 2, that's not true. No solution. No number. There's no number that you can plug in that'll make this equation work. So before class, you're going to write an equation that your partner, we're going to put you in partners, is solved. So make sure before you come to class that your equation actually works. I don't want it to be a no solution or a infinite solution. I want it to be one where it's like x equals 7. So make sure you check your problem before you do it. Since this was a long video, I will entertain you at the end, and I'm going to show you one of my many talents. I tried out for the jazz band when I was in 9th grade, playing the nose harp, and I did not make it, so I will do Twinkle Twinkle Little Star playing the nose harp. You may practice the nose harp at home. It is a very wonderful instrument. Good night.